Okay, so for determining if this is a monomial or not, yes. Yeah, because it's just by itself. It doesn't have any addition or subtraction, and there's no variables in the denominator or anything.
That one's no.
Definitely no.
Because it has to.
A subtraction in there.
Subtraction. That one's yes. This is no?
That's a no. You
Because
can't have a variable in the denominator.
Okay, you're right.
So the reason this one's a no is because, okay, this one's a no because of the subtraction. This one's a no because of the variable. This one?
Yes. It's a no. Yes.
Yes. No.
Yes, yes. Okay, I got that one.
Okay,
So why is that one a no?
no addition. No addition or subtraction. So here, I'll write it down again. So no addition or subtraction. No variable in the denominator. And then you can't have a variable under a square root. Okay. So what I have here is multiplication. So this is a squared times a to the third times a to the sixth. So I'm going to add all of those exponents. So 2 plus 3 is 5, plus 6 is 11. Okay. If there's no exponent listed, it's like a little invisible one. Okay. So I have y squared times y to the 1, that's y to the third, and then z times z squared is z to the third. Okay. A squared times a squared, so 2 plus 2 is 4. B to the fourth, b squared.
Always add exponents, right?
When you're multiplying, yes. Now when I have a number and a letter, the coefficients get multiplied. So, sorry, 2 times 3 is 6, and then x squared times x to the fifth is x to the 7th. Same, 4 times 3 is 12, x times x to the third is x to the fourth, y to the third times y to the fifth is y to the eighth. Negatives and positives, those rules all stay the same. So negative 15 m to the 11th. Now here is where I'm taking a power to a power. So this is where I multiply the exponents. So 10 squared times 10 to the third is 10 to the sixth. Which is 1 million? Yeah, 6 zeros. Okay, that's fine. The 2 here goes, and it squares that negative 6, and it squares the p. So that's negative, here, let me rewrite that. That would be negative 6 squared p squared, which is going to be 36p.
Okay. Wait. Why is there only one p now?
Squared. Sorry, thank you. This 2 goes to the 3, goes to the p, and goes to the r squared. So it's going to be 3 squared, p squared, r to the fourth. 3 squared is 9. So 9p squared r, it's a terrible r, r to the fourth. Okay. I squared the 3 and the p and the r squared. When you're dividing exponents with common bases, you subtract the exponents. So let's say I have x to the 6th divided by x squared. I'm going to do 6 minus 2 gives me x to the 4th. Now, if my larger number is in the denominator, I'm still going to subtract, But because the larger number was in the denominator, the larger exponent, then it stays in the denominator. So it's going to be 1 over x to the 4th. So it's kind of like a tug of war across the fraction bar. The bigger number wins by however many the difference was. Does that make sense? So here I have 6 to the 5th over 6 to the 4th. Well, that's 5 minus 4 is 1. 4 minus 2 is 2. Remember, there's like a little invisible 1 right here. 3 is going to win that war, so it's going to be 1 over m squared. When I have numbers, I reduce those or divide those. 12 and 36 both divide by 12. Oops. So I get a 3 in the denominator. N to the 5th minus n to the 1 gives me n to the 4th. So I have n to the 4th over 3. If I have multiple variables, I go, okay, 3 minus 1 is 2. 5 minus 2 is 3. Now, if I come over to number 10 really quickly, I have a 7 and a 3. That's cool. But I have a 2 and a 2. 2 minus 2 is 0. They cancel each other out. So anything to the power of a 0, this is just kind of like another one of those rules. So if I take anything to the power of 0, so I could take like infinity. If I raise it to the power of 0, it equals 1.
So number 8 would be 2. X2. X over 2 or x over 2.
Yeah, x over x squared. X squared, yeah.
How would that?
We don't allow negative exponents. So when you have something like number 14, where you have, I'm just going to do x to the negative 2. You have to flip it to the other side of the fraction. So basically, if it's negative, you throw it in the basement.
But then it's not a monomial.
Correct. But if it's we don't allow negative exponents. They're illegal. So if it's negative, you throw it in the basement. If it's already in the basement and it's negative, you throw it upstairs. Okay. So when you have a problem like number 14, this becomes 1 over 4 to the 4th. And number 15, that becomes 1 over 8 squared, so that one's easy enough, so I'm just going to do it 1 over 64. When there's a fraction inside already, you're going to flip the fraction. So 5/3 to the negative 2 becomes 3/5 squared. So then that becomes 9 over 25, because just like we do with multiplication, we distribute to the 3 and to the 5. This 9 over 11 to the negative 1 becomes 11 over 9 to the positive 1. Yeah, I squared each of those individually. Now, when I have a problem like this, 18 with this negative exponent, I'm going to take this h to the negative 6 and I'm going to bring it upstairs because I don't want it to be negative. So that's h to the 3rd, h to the 6th. Well, that's multiplication, so now I can add them. When I have a problem like this one, I have this k to the negative 6. I don't want that, so I bring that downstairs. So this is k to the 0, k to the 4th over k to the 6th. Well, 0 plus 4 is 4 over k to the 6th. And now I have a subtraction situation where k to the 6th is going to win and give me k squared. that make sense? So anytime you have that negative exponent, flip its side and then do the rest of it. Here I have two negative exponents. And then there's nothing else I can do with any of that, so it's done. Okay. When I have a fraction like this with a power on the outside, I'm going to square the 4, the p to the 7th, the 7, and the r squared. So that fraction or that exponent outside goes to every single thing inside. So I'm going to get 4 squared, p to the 9th, 7 squared, r to the 4th.
Simplify like that.
Mm-hmm. Unless you can divide the 16 and the 49,
Okay.
but I can't. 16 divides by 4 and 2, 8, 7. 49 divides by 7. So, problem like here, 21 and 7 divide. 5 over 4, 5 under 2. Okay. 32 divided by negative 8. You can bring the negative up top. It looks better. 3 over 1, 2 over 1, 5 over 2.
Wait, number 11 would be a monomial, right?
Not anymore, no.
Okay.
When
So
you multiply monomials together, you get another monomial. But when you divide two monomials, you may not get another monomial. Does that make sense?
Okay. So even if it's not a monomial, we're still going to be
Simplifying it, yeah.
Okay.
Yeah, this is just division of monomials. So,
It'll get more.
yeah, that's called being closed or not. So when you multiply monomials, it's closed. So if I take a monomial and I multiply it by a monomial, I always get another monomial.
Mhm.
But when I divide monomials, I may not. It's kind of like how
Like
when you divide integers.
and you have to flip the signs or something.
Yeah, well, I was gonna say it's how like if you can divide integers.
Mhm.
If you multiply integers, you always get another integer, but if you divide integers, they don't always divide evenly, so you might get fractions or decimals or whatever. This is kind of the same thing. I can multiply monomials and I always get another monomial, but when I divide them, I may not. Does that make sense? Okay.
And I already got one.
Monomial means single, like one term, one part. So it's created using multiplication or division. There's no addition or subtraction in a monomial. It can include variables, numbers, and exponents. However, variables cannot be in the denominator, and they cannot be under a root. If it's under a root, or if it's under a denominator, it's not a monomial, technically. Yeah. Okay, so examples of monomials. I mean, you've seen things. Not green. You've seen things like this before. 2x squared. That's a monomial. 3xyz. That is, it's a monomial because it's connected with multiplication. You're fine. Things that are not a monomial is 3 divided by x. I can't have x in the denominator. I can't have a, b over c. I can't have any variable in the denominator. I also cannot have a variable under a square root.
So it just can't be divided?
Yeah, it can't be divided by, it can be divided here. I could do x over 4. That's okay.
It can't be on the bottom.
It's just that the variable can't be on the bottom. And the reason the variable can't be on the bottom is because then when you're solving it, you multiply both sides by the variable and you end up with different things that aren't, it's weird. So, no variables in the denominator, no variables under square root, no addition or subtraction. Okay, it has to be a single clump.
Could it be negative?
It can be negative. Negative's okay. Negative's fine, positive's fine. It just can't have addition and subtraction between two things. Exponents are fine. No exponents are fine. Numbers in the denominator by themselves, fine. Just no variables in the denominator, no variables under a root, no addition or subtraction between two things. So like I said, it has to be kind of like a clump, if that makes sense. Multiplying monomials oftentimes involves multiplying exponents with common bases. Okay, so this is our exponent. This is our base. Okay, so the number on the bottom or the variable on the bottom is the base. Okay, if we multiply exponents with common bases, we add the exponents. Okay, so an example of that is if I take, like, say, x squared times x to the fifth. I compare that these are both x's. Since they're both x's, I add the exponent. So it's 7. Another example. No,
You just added those exponents.
uh-huh. If I have 2, I look at the x's. I have a 2 and a 5, I add those. I look at the y's, I have a 3 and a 7, I add those. So if the bases match, the x and the y, or x matches x, y matches y, and you're multiplying, you add the exponents. Does anybody want to know why that works?
Because the bases are like,
Yeah.
the exponents are,
Because x, that's 2 times, so you get 5 x's.
Here's why it works. Because x squared is x times x, and x to the fifth is x times x times x times x times x. And then when I multiply them all together, there's 7 x's. So basically, you're literally adding up all your x's. You just don't want to have to draw that out every time, because if I told you x to the 26th times x to the 54th, you don't want to draw that many x's. Now, when we have a power raised to a power, so I take x to the third and I raise it to the power of 5, like this, we're going to multiply the exponents. Okay, so x to the third to the fifth is the same thing as x to the 3 times 5, which is x to the 15th. Huh? Do what? If they're inside here?
Yeah.
Okay, so let's say, for example, I have 2x squared and I raise that to the third. It's sort of like distribution with multiplication. I'm going to distribute the third here and here. So this is going to give me 2 to the third x to the 6th. And 2 to the third is 8. Does that, yeah. Look on the packet that I gave you guys. The second page is 7.1 skills practice. That's where these problems that we're doing right now came from.
okay.
So they're in the packet. Am I recording right now?